So question 4 from 2017, it seems weird at first and it's kind of tough to understand, but once you kind of understand it, it's actually not that tough of a question. So I'm going to try to do my best to explain it. It says the chemicals in clay used to make pottery can differ depending on which region the clay originates from. Sometimes archaeologists use a chemical analysis of clay to help identify where a piece of pottery originated. Such an analysis measures the amount of a chemical in the clay as a percentage of its total weight of the piece of pottery. The box plot below summarizes analysis done for 3 chemicals X, Y, and Z from 3 different sites 1, 2, and 3. So you got 9 box plots here, right? It talks about chemical X at site 1, chemical Y at site 1, and chemical Z at site 1, and then same thing at site 2 and same thing at site 3. So part A says for chemical Z, so we're only looking at 1, 2, 3 box plots. Describe how the percents found in the pieces of pottery are similar and how they are different. Really, this is nothing more than a SOX problem comparing 3 distributions. So let's see what I wrote. I wrote, at all 3 sites, chemical Z. Oh, I fixed that typo. Apparently that's not updated. Chemical Z has a median of approximately 7% of the weight. So center, 7%, 7%, 7%. So it's very similar medians. That's the center part. I just went in a weird order, but that's fine. The range of chemical Z is smallest at site 2, about 2%, and largest at site 3, which I said went from about 3 to 11, so that's about 8%. Now, I didn't say all 3. You could say all 3, but you should quantify it with values, right? Don't just say it's smallest at 2 and largest at 3. Be more specific. We have the data right there. We can do it. And then I said all 3 sites have an approximately symmetrical shape for chemical Z, right? Symmetry, 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 right? I'm not going to say normal because we don't know that, but I can say symmetrical. Now, part B. They ask us 2 separate questions. Part B says, consider a piece of pottery known to have originated at one of the 3 sites, but the actual site is not known. So they just say, here's a piece of pottery, this is the information we have, what site is it from? So question 1 says, suppose an analysis of the clay that they found reveals that the sum of the percents of the 3 chemicals, X, Y, and Z, is 20.5%. Based on the box plots, which site, 1, 2, or 3, is the most likely site where the piece of pottery originated, and justify your choice. So there's 2 ways I thought of to look at this. One way is if they all have to add up, the 3 chemical weight percentages add up to 20.5%. What I just did was I added together the approximate medians and saw which one is close to 20.5. If one of them is close and the other 2 aren't, then that's where it probably originated. So if you look at the medians in site 1, if you add the 3 chemical medians together, 7 is 14 plus 13, 27. That's much bigger than 20.5%. At site 2, 6, 9, 7 is 16. That's less than 20.5, but 7, 7, and 6 is 20, and that's really close to 20.5. So that's the way I wrote it out, and I'll write that in a second. But I just want to talk about another way. Remember, the ends of box plots are the max and the min. Max, min, max, min. If you add together the 3 mins at site 1, that's about 11, 4, and 6. 11, 4, and 6 is 21. So if you had the smallest of each chemical at site 1, that would be 21. That's still greater than 20.5. So even on the most extremes, the minimum is still greater than 20.5. And if you think about that here as well, here we'd have to use the maximums to see, well, if you get 8, about 7 is 15, and 4 is 19. If you take the 3 maximums, it's only 19, which is still not 20.5. So that's another reason that site 3 is the correct answer. So I wrote for part B, part 1, sorry, I wrote, so B1, I wrote site 3, since the sum of site 3 medians is approximately 20%, while site 1 is way above 20%, and I wrote approximately 27%, and site 2 is way less than 20%, approximately 16%. Okay? Now, question 2 says, suppose only one chemical could be analyzed in the piece of pottery. Which chemical would be the best one to choose, the most useful in identifying where the piece of pottery originated? So to do this, I'm also going to counterexample it. If you choose chemical X, well, let's say I say, okay, we're going to analyze chemical X only instead of X, Y, and Z. And I get, let's say, 6% of the weight of chemical X. Well, what site could it be in if you get 6% for chemical X? Well, it could be in site 1. If I look at like this line here, it could be in site 1, site 2, or site 3. So chemical X is not a good chemical to choose because there's a lot of overlap. And if you do the same thing with chemical, let's look at Z now, you could see if I draw a horizontal line, there also is overlap. So if you only look at chemical Z, it's not going to be very helpful either. So what's going to be the one that's best? It actually ends up being chemical Y. Let's take a look. Why is that? Because as you can see, this box plot, and this box plot do not overlap. So if you only look at chemical Y, you will know where the clay originated from, site 1, site 2, or site 3. So chemical Y is definitely the best. So part 2, I wrote chemical Y. Since there is no overlap in any of the box plots, you can easily determine which site by locating in which box plot that weight percent is located.